Okay guys, more 3D printer upgrades. I think you guys liked my last video, so I thought I'd do another one on my next series of upgrades. Oh, forget that acetone. This acetone isn't part of the video. We don't need that. So today, we're going to be taking a Creality Ender 3 Pro. On the last video, I upgraded the motherboard in this machine to that 4.2.7 board. I also installed this BLTouch for auto bed leveling. So what we're going to be doing today is something a little bit different. We're going to be working on the extruder mechanism. We're going to be installing a direct extruder, which is this part right here. And we're also going to be installing a second Z-axis right here. So let me talk to you about these parts a little bit and why I'm deciding to do this. So I'm trying everything in my power to maximize print quality out of this machine. And also, I guess, dimensional accuracy, because I use this printer a lot for work, and I want to make sure that this thing is in tip-top shape, and I'm squeezing every ounce of value I can out of it. And from what I've read online, I haven't confirmed this experimentally, obviously, because I'm just seeing these parts for the first time. One of the factors that contributes to low quality is obviously a bed that's not flat or level, which we took care of with the BLTouch. That was a phenomenal improvement on the first layer. But also the whole Z-axis thing and this extruder mechanism. So right now, all the filament has to come down from the spool that sits up here, goes down here into this feed mechanism through this Bowden tube. I'm not sure why they call it that, but that's what it's called. This tube right here, and down to the extruder. And this tube and this wiring bends and flexes, and I don't know. I guess the filament can get caught up in there. I don't really know all the details, but from what I've read, this contributes to a decrease in quality. The fix for that is this bad boy. So I think that this direct extruder, which essentially replaces this whole mechanism right here, it sits on that axis like that. There's a very small and minimal tube in there. I think it's a very, very small tube right in there. So that tube is drastically reduced in length. So instead of the filament following that blue Bowden tube, it just goes right down into this hole on top of the extruder. So I think it's a much more efficient setup. Couple things I don't like about this kit right out of the box. I mean, just looking at it, I don't know if you guys can tell that, but it looks a little wonky, doesn't it? Like, it looks out of square almost. So I don't know if we can fix that or what, or if it's an issue. Maybe just the guy that put it together in the factory wasn't paying attention, but hopefully we can correct that. Another thing I don't like about it is this mechanism here. So this is the mechanism that you use to load the filament in, right? And come on, can you see that? Focus. There we go. So this is just like that stock plastic mechanism. I already bought an upgraded mechanism that's out of, looks like sintered powdered metal in the back. You can see it's kind of that silvery looking thing there. I already bought that. So now I gotta hopefully swap that over to the new one, because otherwise I'm doing a downgrade there. So yeah, out of the box, that's kind of what this direct extruder is for, and the problems it solves, and what I like and don't like. Hopefully the BLTouch can mount to that. It looks like this bracket will transfer over, but we'll try that out. One of the downsides of this direct extruder mechanism is its extra weight. And what I've heard is that because that weighs more, keep in mind your Z-axis screw is over here on the left side, right? So this is the only support vertically for this mechanism here, for that bar. When this extruder is all the way over here, it adds extra weight, and it can cause sagging on that side, which can deform your parts. So the fix for that is this second Z-axis kit over here. So this installs a second Z-axis on the right side of your machine to match the left side. So you're going to have a Z-axis here and a Z-axis over here, I think. So hopefully with these two kits combined, we'll solve some of the print quality issues, or I guess some of the only remaining print quality issues that I can fix in this machine. So I guess without further ado, let's get into it. And obviously, as always, I'll leave links to these parts in the description, so if you guys want to pick these parts up yourself, you can. Let's start with the second Z-axis kit. Thankfully, it comes with nice color instructions. It looks like it's a pretty straightforward process to do this. Hopefully it comes with all the parts that you need, a bracket, a bunch of fasteners. So looks like the first step we got to take the power supply off. Let's do that. Now if you're watching Joe's Garage, this probably doesn't apply to you, but if you lost all your 3D printer hardware that came with it, like all the Allen screws and everything. It looks like it comes with the new hardware bag, so that's a nice touch. Now you got some spare tools if you need them. I have my own Allen keys. I don't even know why I'm using these. But who cares, right? So there's our power supply off to the side. Next, they want you to put this coupler on the motor. Notice that the motor has a flat ground into the shaft, which is a nice touch. It makes it easy to index things under the shaft, but there's no flat in this coupler. Just round, so it just clamps on. I mean, I'm sure it's a sturdy design, but it could be better. I mean, if you can clamp onto that flat, why not, right? So just tighten that bottom Allen screw. I don't know if the clearance matters yet. I guess we'll find that out. And let's see, now it looks like we have to put this Z motor bracket onto the motor. Now in the picture, they have this bracket with that little semicircular portion cut out facing the coupler on the opposite side of where the wiring harness is. So our wiring harness connector is there. So I believe this gets mounted like this. I'm leaving this bracket deliberately loose just so I can align things first, and then once we have everything aligned, we'll snug those bolts down. Now we have to remove the right side, or I guess the pulley mounting screws on the right side of the x-axis. So this one here, that one, and there's one buried in here too. Just for giggles, I was looking for a backup wrench to hold this nut and nut down there. I thought I'd go into my tool collection rather than the tools that came with the printer, and those nuts appear to be some kind of non-standard size. I tried metric and SAE, and ironically the best one that fits was a 5/16 standard, but even that's a little loose. And it appears the same thing might be true with the wrench that came with the 3D printer. Just, I don't know, just some kind of non-standard bolt size? I don't know, why would they do that? I don't know. So let's go back to using the tools that came with the printer. Thankfully I still have them. Why would you engineer something with non-standard fasteners? Boggles the mind. Okay, so there's one. Just do that for the other three. I mean, other two. This last one's a bit annoying. Maybe I need to stick this in there, just in case it's moving. Yeah, I think it was. There we go. This seems to be the better way to do it. Hold the nut, turn the wrench. Okay. Not sure what else is holding that wheel in there, but oh well. It looks like to get this last screw out, this bracket needs to unbolt from the actual axis because it's like kind of caged in there. Didn't really say that in the instructions though. I think that bolt has to be replaced because the screw that you have to use is longer than the one that's there. So I don't think it's just a simple matter of bolting that bracket up. You got to physically replace the screws. Maybe there's a better way to do this and it's just not mentioned and I'm not seeing it, but I think we got to unbolt this bracket from the axis. Again, it doesn't seem like that's really well identified in the instructions in my opinion. Because they do give you three longer screws. That kind of implies you're going to need them, right? So there, I'll just take this screw out. And we'll put one of the longer ones from the kit in there. And we'll just remount this bracket. Hopefully. Where were those screw holes? There we go. There's one. I guess I shouldn't be too surprised that Creality instructions leave something to be desired, right? I don't know how important. There's quite a bit of room in here for this thing to move around. Hopefully the position doesn't matter a great deal. Just gotta snug down these bolts. Make sure this thing doesn't move. We'll put this cam thingy back in here, like so. Get this wheel mounted back, like that. Now, the wheels, I think they give you an extra spacer. They don't really call out too well in the instructions. So I believe the way it's going to go, they give you 3 of these screws, right? These longer screws. They also give you 3 of these aluminum spacers. So I think it goes like this. I'll line it all up for you. So I think the order of assembly is somewhat like that. So this part's the back, this part's the front. Let's actually assemble it and I'll show you. Can you guys see okay? Hopefully. So I believe it's going to go something like this. So you're going to have this goes on, this that goes on here. You're going to have a bolt. I think all those spacers are the same. Yeah, they are. You're going to have a spacer. You're going to have the wheel, like that. And then another spacer. Whoops. Like that. That's how it looks to me. They want it to go. Let's do the other side. Grab another one of those spacers. Oop, I missed a spacer on the front there. Let me get that one before I forget. Or before it's impossible to do it. There we go. There. So again, we have bolt, spacer. You guys can't see, can you? Bolt, spacer, wheel, spacer. Without these spacers, you'd crush the wheels. Or you'd bend the bracket, one of those two. Either is a good thing. So now that you got that, should be a simple matter of just snugging up these those odd size nuts that we took off before. And that's kind of what your final assembly should look like. Obviously not tightened yet. And you got that one there. Let me snug those up and we should be good. Okay, so now everything's snugged up. And that's kind of what the final assembly looks like there. Now, if your printer has a lot of hours on it, now might be a good time to change, well, would have been, not anymore, would have been a good time to change these wheels if they look really warm, but mine are okay. I need to tighten this because these shouldn't spin so freely. And you can adjust that with this kind of weird looking, there's one, wait, are we off on something here? What's going on? Shouldn't spin like that, should it? Might be tight, maybe we'll adjust that later. Yeah, there we go. So if you need to adjust that assembly there, you can turn that nut right here, I don't know if you noticed before, but it's kind of on a cam. You can turn this nut to adjust the tension on those wheels. So that kind of goes for all the other parts in all the other wheels in your Ender as well. If you find that there's bed slop, like if your bed wobbles side to side, you can adjust those eccentrics and tighten things up. If you max out the adjustment, then you got to replace the wheels though. I just grabbed this Z-axis screw and shoved it down through this bronze, what looks to be oil light bushing. So let's see, what's the next step? Install the motor and cable is. Wow, really trustworthy instructions, huh? So I'm assuming they mean this needs to go down here. So let's unscrew this a bit. Slide our motor with those caged nuts in there, not caged, but slotted nuts that fit in the grooves in the axis. There we go. And let's tighten the motor. Well, let's snug it. We don't want to tighten anything yet. That's just asking for trouble, right? Oh, and if you get confused, it looks like the motor bracket on this side is the same as on that side, the side you already have. So if you get lost, fear not. So how does this work? I don't think I want to install this lead screw yet. It's in the way. Do those nuts, do you have to turn them somehow? I'm trying to remember how I did this. Or have I? Have we used these screws before in anything on this printer? I can't remember. I barely remember what I had for breakfast yesterday. Okay, so that one turned. There, that one's turning now too. Okay, we're good. All right, so that bracket isn't super tight, but it's tight enough where it's not going to walk around and go places. So the motor can still be moved around a little bit. I'm going to leave the motor loose just so we don't have any binding going on here. Because if the motor is not aligned at the bottom with the bushing at the top, which the other one doesn't really have for some reason. I think it's kind of odd, isn't it? Well, anyway, if it doesn't align, then you're going to get binding, and binding is bad. Where was the Allen key for that one? Oh, come on, I know I had it somewhere. I don't know what I did with it. It's probably under the printer. So now notice our whole assembly can slide around a bit. I think that's good for now until we get everything lined up. So they give you these brackets. Wonder where they go. What did I do with my instructions? Really? Are they under the printer? Oh, here they are. Behind the printer. Okay, so it looks like they give you a bracket for both the left and right side here. So left and right. That's kind of cool. And I'm jumping around a little bit. Let's go back to staying in order. So now they want you to hook up this wiring harness. I'm on step 5 now. And it looks like you simply detach the harness from your existing motor. You plug it into this Y harness here. I wonder if this is going to cause any problems with the driver on the board. Because now you're asking the board to drive twice the motors, unless I guess twice the current, right? Or probably almost twice the current, not exactly twice. Because this motor is going to be, in theory, have less load on it. The other motor is doing half the lifting. Alright, so we got that plugged in now. So now we're going to install this power supply holder bracket right here. It looks like that just goes on this rail. It has clamps that bite into the grooves on the rail. I think. There we go. Did those things turn? I think they did. Let's slide this a little bit further forward. Actually, no, let's move it back here because we may need to adjust things. There's a power supply on here. So how does this go? I give up. Not really. They give you 2 brackets? What's this other one? I don't know what screws we're supposed to light into here. Okay. Let me study for a moment. Oh boy, you guys didn't have the mic on, sorry guys. Hopefully you heard some of what I was babbling. Let me see if I can figure out how this power supply mounts. Alright, I think I figured it out. I'm a dunce. Those instructions really are not very good though. So I think this has to come over here. Like that. I guess there's a bolt here that you got to take out. I hope. I think that gets transferred over to here. Like so. Again, I'm assembling everything loose for now because who knows how well it's going to fit. And then I think this guy gets mounted here. Let me give you a couple screws here. Can you guys see this okay? Let me turn the printer a little bit. Is that better? Let's get one in there first. Let's not be too ambitious. Hopefully these holes are threaded. Oh, look at that, they are. I think. Are they threaded? Oh no, those are there's already screws in there. Am I wrong? Okay, after some fiddling, I think I figured it out. So this bracket down here, I think one screw goes in the power supply there. And rather than taking one of those frame bolts out down there, I think you're supposed to do one of these guys in the back there. I think. So let's see if that all bolts together now. So let's see, can we get, is this the right size? Yeah, I think so. Let's get this guy in the frame rail. Let's tighten it down a little bit. Okay, that's in there, or loosely. Now let's see if we can get this power supply bolt back on. What we had on before. Maybe, kind of. Man, this thing is a pain in the neck. That bolt doesn't want to fit in now. Talking about the single bolt back here. Now it doesn't really line up. Not yet anyway. Oh, there it goes. That might be it, guys. Maybe that's how you're supposed to do this. It's kind of a weird power supply mount if you ask me, but I guess it works. Is it mounted? Yes. Is it super rigid? Not really. I don't know if there's like another fastening point here, is there? Maybe it doesn't need to be any more rigid than that. I don't know. If I'm doing something wrong, let me know. Not a fan of these instructions for sure. Okay, so now what's the next step? Zoom you back out. That's kind of what it looks like at the end. There's no screw hole in the power supply there, so I'm not going to make one. And then you have that set up down in there, again with one of those little nuts that hits the frame rail. So it's a little loosey-goosey, but it kind of stays in place. Okay, now we're supposed to install these Z-axis holder thingies. Oh, I guess they were in a bag that you could open rather than tear. Good to know. Whoops, dropped a screw. All right, so I got the motors loose on both sides, loosened the couplers as well. I'm going to install the top brackets up here and up here just to align everything, and then we're going to snug everything down. And these brackets are held in place with those little rail nuts, just like pretty much everything else. It's a pretty tight fit on this screw. Is it supposed to fit at all? Doesn't spin on. There's a ball bearing in there. Tighten the screws. Man, they are tight. Let's see if the other one's just as tight. Well, maybe I have them upside down. Yeah, probably. Probably supposed to go like this. Yeah, it seems better. So, word to the wise, looks like the ball bearing side goes up like that. So let's get these mounted. Okay. Again, this is just to position them. We're not tightening anything yet. We want to make sure that Z-axis turns smoothly. Okay, get the other one in place. That. Some people online say that these upper blocks are more trouble than they're worth, but I figured I'd give them a try. What do I got to lose, right? Is this, wow, that's lock solid. Okay. Loosen this a little bit. Okay, so this can slide side to side, okay. Man, you can't move that at all. Can we turn the lead screws? Yeah, they kind of turn, right? All right, now we just have to align everything and snug all the bolts down. Now it's kind of a sanity check when I'm doing my final adjustments. I'm taking a bubble level here, making sure that's roughly level. Obviously, I make sure the machine's level. You want to make sure it's parallel with the bed. Now with the BLTouch, it should kind of account for any irregularities, but things should move a little bit smoother if they're properly aligned. So let's see, we gotta bring this side up a tad, about like that. I'm just making very fine adjustments to this screw to make it kind of match where the bed is in the bubble level. That looks pretty good. I think we'll snug that down. And everything should turn pretty smoothly by hand with minimal to no binding. Feels pretty smooth to me. And you want to make sure that this is aligned up here where it's the smoothest. Because if this doesn't form a perfectly straight line, you're going to get binding. Feels pretty good. I did notice that these Z-axis shafts are a bit different in length, and I guess that's okay. This one seems to be sitting a little bit lower in the bearing than this one. In fact, this one might be a little proud of the bearing. Not a lot, but enough where you can notice. So it seems to be okay. Moves around okay. All right, so that might be the end of this enhancement. Hopefully it is an enhancement. I think what I'll do before we do anything else, I'll do an auto home procedure and just make sure things move up and down smoothly. Okay, she's booting up. Let's see what happens. Let's bring our Z-axis all the way up. I guess one drawback is you can't move the Z-axis too easily with your hands anymore. Let's bring it pretty far up. And put a dab of oil on that bushing too. I like using this stuff. I'll leave a link in the description. I've been using this for years. It's a really good lightweight oil. Good for bike chains too. So I'm just oiling that Z-axis rod ever so slightly. Put a little bit of oil in the bushing itself. Okay, let's see what happens. Let's do motion, auto home. Doing its thing. It's going up, going down. Seems to be okay. I don't hear any nasty noises. Cool. I would say that's a success. All right, so let's move on to the next upgrade, which is going to be the direct extruder. The axis really doesn't look level, but maybe it's just some kind of optical illusion or something. Anyway, on to the next. Now on to part 2, installing the direct extruder. You might be wondering why this is in the 2 videos rather than 1, but I figured since this is, at least my research indicates this, that the Z-axis, the second Z-axis kit is kind of required equipment for this. I thought it best to just do them together. So in true Creality fashion, we get some more tools, we get some more wrenches, and we get a wiring harness. How nice. So I think the first thing I'm going to do here is I'm going to take everything apart and make sure that this, I don't even remember what it's called, the thing that lets you insert the filament, that metal one versus the plastic one. I'll make sure that fits. And of course they give you no installation instructions for this one. They just give you a picture of the motherboard. An old one at that. So we're on our own with this one. Should be fun. First things first, time to remove that guy. Because again, we want to install this on the new part. I remember it being kind of a pain in the neck. Okay, so we got that loose. That's right, that screw has to come out before we can do anything. We're going to take that last screw out. Let me cut that zip tie too. Just keeps the harness out of the way, but don't cut the harness. There we go. Do you guys talk to yourselves too, or is it just me? Yeah, that's what I thought. So there's nothing wrong with this extruder. It's just, I think we're better off with this direct extruder. Plus I get a whole new extruder. This extruder got some time on it. This is kind of replacing the business end of the printer. So I'm going to look at it. We're going to find out pretty quick if this thing is compatible with with the direct extruder. I think it will be though. I didn't see anything that jumped out at me that was different. I guess one thing I could have done is taken the new one off and just made sure it looked like the one that was the old one that I took off the printer when I installed this one. Come on. Tight quarters here. 68 miles of threads later, that piece is off. Now we get this last bolt out here. The motor should drop as well, so have your hand on it. Okay. Let's set our motor aside. We'll disconnect our Bowden tube here. Pull out our filament. There we go. Let's see if it fits on the new one, right? First step is we have to take this motor off. Are these screws yet a new size? Let's see. They're not even that tight. Okay. Let's see if things look kind of similar here. Set those screws aside. So we got some kind of spacer thingy. I think this is going to work. Maybe? Yeah, it just goes like that, right? Is this going to fit over here? Yeah, I think this this metal kit's going to work just fine. All right, let's give it a shot. So now we're going to take the plastic piece off. Never had one of these break, but a lot of people seem to have problems with them, so I don't even mess with them anymore. Okay, sweet. Let's get that out of the way. Get that spring out of the way. Okay. Just using the tools that came with the kit, nothing more. Okay. Now let's put this bad boy on like so. I don't know why Creality just doesn't include this part in their kit. How much would it cost them, right? It's not an expensive kit. So I think it went something like that, right? Let's get this one started. Have to get our spring in there. You guys probably can't see a whole lot, I'm sorry. Maybe that's better, hopefully. Okay, so that mechanism seems to work. Oh, but I shouldn't have done that yet because I got to put a mounting screw in there. Stupid design, huh? Can't fix stupid. Now, will this bracket sit flush afterwards? Guess that remains to be seen, right? All right, the only problem I've seen so far is this piece has to go here, right? That's how it came off, but then nothing constrains this spring perch from going side to side. There was a screw, but I'm not sure if it'll clear. I don't know, should we modify the kit? What do you guys think? I suppose it wouldn't be too tough, right? Yeah, so at this point I'm pretty sure that this metal kit here was not designed to work with this direct extruder, unfortunately, but I think I found a way to make it work. So the screw that goes in here that kind of constrains that spring assembly that I showed you, that screw's not going to fit going in this way. And it's too short going in this way to constrain it. So what I found is I found this other screw in my bag of 3D printer parts. I think we can make this work. Let's try. I don't know if it's going to work yet, but... So what we'll do is we'll take this screw, we'll thread it into this piece backwards. Or who knows, maybe I just did this whole thing wrong anyway. I have to cut this down too. And I'm thinking that can go in like that and constrain it side to side. Oh, you know what? That's not going to work either, because then this thing isn't going to be able to open all the way. I don't think anyway. Let's see. Yeah, I don't think it's going to work. Crap. Maybe what I can do is take a piece of threaded rod or something and thread it in there and then cut it off so it's flush. I don't know. What do you guys think of that idea? Can I take this screw and just cut the head off of it? All right, I think I figured something out. So that previous kit, the Z-axis kit, had some leftover screws, and I had a bunch of these screws that were left over. It's the same thread pitch as this hole right here. So this just threads in there. Right? So that could act as a stop for the spring to keep it from going side to side. Two problems. One, the head of the screw is too big. It doesn't fit inside the spring, but we can fix that with a grinder. Another issue is it's sticking out too far. So we could just put some Loctite on there and keep it out a few turns, but I think I might just cut those threads off. This is a pretty small screw. So let's, I mean, we're not going to hurt anything. I have spares of these, so let's try to modify this screw and see if we can make it work. I'm going to take it up to this bench grinder up there and just grind the head off a little bit. See if we can't break anything. I know you guys are always on me with safety glasses, so here they are. I'm putting them on. Appreciate your concern. What I'm doing is I'm using the Allen key to turn it. It's going to get hot. I can turn it easier like this. Probably need to dress this grinding wheel. It's all V'd out from grinding tungsten for my TIG welder. Let's see if that fits. Whoop, and I dropped it. Wonderful. Okay, I think we got the head ground down enough. Let's do a little test. Didn't grind it to length yet. But that works. That'll keep the spring constrained. Now we just need to grind it down. How are we going to do that? Normally when I grind or cut screws, I like to do it in such a way that there's a nut on them to chase the threads when I'm done. Don't know if I have a nut this size though. This is pretty small. Yes, I said small nut. Get finished with your jokes. So it looks like I'm going to take like 3 or 4 threads off of this thing. Just marked it with a Sharpie. Normally I don't like to do this, so I'm just going to grind this screw down freehand on the grinder. Do my best not to mess up the threads. I only have to go down like 2 or 3 threads. It shouldn't be that difficult. Let's get a pair of needle nose to stabilize it. Yes, I got my safety glasses on. That might be it. Told you it wasn't much. Let me go a little bit more just to be on the safe side. Just grinding off the burr. Hopefully that'll let the screw go in smoothly. Just gotta cool it off now. Okay, I got the screw ground down. Fits perfectly. I would argue this is better than it was before. And this spring fits through it like that. So it's just a stop for the spring. Unfortunately, when I was doing all this, I realized that these parts are a little bit dimensionally different. So if you line up this spacer, you can see light through the bolt holes, right? I realize it's probably a little blurry, but here, something's a little bit different on this one. Not much, but enough where the bolt holes don't line up. So I can probably grind a little bit of plastic off that surface right there and that surface right there. Let's give that a try. All right, I think I got everything ready to go. So I got the metal extruder thing, I don't know what you call it, but it's mounted. Works okay. I got this bracket trimmed down. It's not pretty, but I think it's functional. And now we just got to mount this to the 3D printer. And this tube, I think, is just going to, I took out that threaded fitting there because it wasn't going to fit. I think we're going to be able to make it work though. So let's see. So this should be something like that. Let's get our screws, get them ready to go. Just doing a little bit of this off camera. It requires a few hands. Just getting a couple threads in these screws. It's a shame Creality doesn't just make this kit for the direct extruder. Maybe they do and I'm just an idiot. That's entirely possible. I've been called worse things before. Square it up a little bit. I think that's all there is to it, right? Let's take a piece of filament and see if we can actually get it through that tube there. Let me go cut a piece. All right, let's give it a shot. So I got a piece of filament in my hand here. Just gonna open this up and make sure it goes down far enough. So I'm just gonna be able to see how far down I can shove it. That's what she said. Yep, it seems to work okay. It's down all the way. It's into the extruder. Cool. Let me just square everything up because it looked like crap before, and then we'll get on to putting the BLTouch on here because to put that bracket on here too. Okay, so I'm just going to take this cover off because this is where the BLTouch attaches to. This is just the heat shield for the extruder. Screw comes out. Another one over here. There we go. Released. So now this, I believe, just mounts like that, but without dropping it. And if I recall correctly, it's easier to mount the it'll be okay because this thing isn't on the machine yet. I'm just thinking out loud. I think it's easier to mount the BLTouch when to this bracket when it's not. This bracket's not on the machine. Let's line up all these screw holes again. So many small parts, man. That's what I always struggle with these 3D printers. You know, all the parts are tiny. Plus the general challenges of filming everything too. I gotta make it so you guys can see, which you could not, I apologize. Gotta deal with really tiny screws. But that's why we like YouTube, right? Gotta keep the fans happy. I wonder if anybody's ever tried to use that metal extruder bracket on the direct drive extruder before. I'm curious, have you guys done that before? It is possible. Can't say for sure it's going to work yet, but it's mounted. Okay. Got our BLTouch mount. Just make sure you remind me to mount the BLTouch to this thing before we put it on the machine. So that'll be a bear. Let's make sure everything's all squared up. It doesn't actually look all that bad. Got to tighten the bolts on the back here. And I think we could start taking the old extruder off the machine. It looks like we're gonna have some wiring to do too. Yippee. Wiring is always fun. Okay. I think our extruder is all prepared. Now let's start disassembling the existing extruder. They do give you an extruder extension cable. Don't forget to plug that in, because the existing extruder is fixed and that cable's short. So this is just essentially an extension cord. So let's cut this open. Where am I here? There. Let's cut this zip tie. Don't cut the wires. There we go. Oh my God. So what is all this? There are wires here without ends on them. Okay, so these don't get ends. That's okay. These just go to the main board, I think under screw terminal, so don't get scared. So we have our fan, we have our E-temp. I guess it's a thermistor. Our fan, our hot end wires, and I guess this might be for what? What's this plus and minus for? Oh, positive and ground for something? I don't really know. Because we have fan, we have heater. Oh, maybe for the thermistor, because the thermistor is going to need that. I think. I don't know. Just going to take a minute to clean up my work area because it's a hot mess right now. I don't want to lose any parts or drop anything. Keep your work area clean, guys. Okay, let's unscrew our old extruder. The easiest way is probably going to be to take that bottom bolt out. I don't know if this thing's on a cam or something. I guess we'll find out. Nope, seems to be coming. Which one is on a cam here? Maybe it is that one. Ah. Need to get a wrench on the other side. And for that, I think we need to take our Z-axis up a bit. Put a wrench on a big nut in there. Then we should be able to loosen it. Maybe it's the other little nut. I don't know. One of these. Really can't see anything. That's so you guys can see. That's not really helping. Oh, let's turn the printer around. Can I get my wrench in there somehow? There we go. We're in on the nut. Can we take the extruder off now? Maybe? No. Man, this bottom wheel is pretty torn up. Or it looks pretty torn up. There we go. I guess we have to unhook our belt too. Okay, so our belt is unhooked. The extruder is free. Now we have to disconnect all the wires. That's fun. Got the bottom bolt loose on the new extruder. Should just be able to slide it on. Maybe. Maybe not. Maybe loosen it a bit more. It's not easy to get that bolt, or that nut rather. It's right next to the heating element. And you don't want to damage that, that's for sure. There we go. That kind of works, right? Maybe tighten it up a little bit. That's pretty loose. Right now, I tightened it up a little bit. There we go. Something like that. Now let's see if we can snug that up without messing up the works here. So that bolt is right here. Probably should have just taken the two top ones out. Would have been easier. Word to the wise, guys. You do that. Don't do as I say or as I do. Okay, got that nut tightened. Now we gotta take out the slat. So for that we'll use our wrench. I think you just gotta turn this hex nut in here to change the position of the eccentric. There we go. That's pretty solid. Might need to adjust a little bit more later. But that's the general idea. We got to put our belt back on, which is where there's a belt bracket here, and there's another belt bracket over here. Might need to adjust our belt tension after this too. But that's the idea right there. So now we gotta flip it over and get to the motherboard and swap out all these wires. That's gonna be fun. Got the printer flipped over to cut some zip ties, and I realized you guys forgot to remind me about the BLTouch. You were supposed to tell me to unmount it before I put the new extruder on the machine. Thanks, guys. Appreciate it. That's gonna make this a lot more fun. Let's see if I can do this while the machine's flipped over. Taking the BLTouch off the old extruder, just taking the bolts out. I'm fully expect to have to reset the Z offset. If you don't, I'd be shocked. Just be careful with this BLTouch, it's a little fragile. Okay, there it is. So our old extruder, got my BLTouch situated. Now we have to take the motherboard cover off. I think it was just in here. Oh wait, it was. The longer screw goes up here. I think there's a screw on top that holds this thing on too. Okay, is this gonna come off? No, I was right, there's a screw on top. All the way in the back, I think. I think it's in a super inconvenient location, if I recall. Let's flip it back over. So this one here. Nice, they just put all the screws on one side, huh? Long screw there as well. And there's a screw in the front. sort of, in the front. I know you guys can't see this, but you don't need to. Nothing to see. That was a short screw. I'm sure there's a joke in there somewhere. Whoop, there's the cover. The cover just fell off. Get that out of the way. Flip her over. Okay. Let's see what we got here. Need to get some better lighting. All right, so we got to keep cutting zip ties. I got another one here. That cost me a fortune in zip ties. Jeez. There's my BLTouch cable. Okay. It looks like the main harness for the extruder passes through this like tape-like material. Probably just cut it, right? How important could it be? So that old one just routes over here. I don't want to, can we unwind it? I want to cut it. I want to cut any of these small wires. Just tear it, maybe? Or we just got to be really careful with a razor blade. I feel like I'm going to regret this. I'm just putting very gentle pressure on this tape stuff, and it's splitting, so that's good. Don't want to cut any of those very small wires. We'll probably just substitute that with electrical tape or something. Okay, there we go. Lots of wires, geez. So we got to isolate which wires go where. Make sure we deal with the right ones. Okay, so this one's going to over there. There's our motherboard. Let me get a little bit lower so I can see what I'm doing. So this is the wire coming from the old extruder over here. So this looks like our thermistor here, right? I think. What's it say on the board? Yeah, TH. So let's just unplug that. Oh, that's right. I put glue on here, didn't I? Watch, I'll break the board now. We're going to take the motherboard out. Definitely feel like I just did this job. Very short motherboard screw. Oh, I'm calling it a motherboard. I guess it's really a control board, right? So while I'm just tooling around in here, I'm curious, what 3D printers do you guys use? Do you guys use this one? You probably do because you're watching this video, otherwise you wouldn't care. Do you guys like this one? Do you love it? Do you hate it? Prefer a different one? Leave a note down in the comments. I mean, there's lots of reviews out there. A lot of really expensive and really inexpensive 3D printers. This falls into the latter category, but have any of you guys abandoned the Ender series and gone with something more substantial? Anybody have one of those infinite axis printers, the one that just keeps on printing and printing and printing with no bed? That thing's pretty cool. Tell me what you guys think. All right, so I'm gonna deal with this glue. Probably cut it off with a knife. So what I did when I installed this motherboard, I put a bead of glue down here just as positive retention to keep everything from coming apart. Did a little bit of work off camera. I just took the old extruder wires off. It's pretty straightforward. There wasn't much to it. The hardest part was just melting the hot glue that I had on the board just for positive retention, or a form of positive retention. Now we just got to put the new wires in there in a logical manner. Maybe we'll go this way under here. And again, everything's nice and labeled, so it's pretty hard to screw this up. Although, that sounds like a challenge. I'm sure I could figure it out. So let's do our fan wire first. Still got the hot glue gun on, so we can redo the positive retention. There's our fan wire. Here's our extruder temp thermistor. Maybe, there we go, that's in. Let's do our extruder wires. These are the heaters. The two red wires coming out of the harness, they go, doesn't really matter which one goes where under the screw terminals. Hopefully you guys can see this. So I'm just putting these wires under here and tightening down the screw. Oh, see, this one didn't take. So you got to try to tug them back out again after you're done tightening them, because sometimes they don't go in all the way or they don't catch the right part of the terminal. So that's in there securely. Let's give it one more turn, make sure they're snug. Don't want to lose connection on these. And you got your positive and negative. Positive is the far wire over here. It didn't catch. There we go. There we go. Got it that time. We'll do our negative, and then we'll put a little bit of hot glue on the terminals, not the screw terminals, the ones that are connectors, just to make sure they don't go anywhere. That's important because this thing's vibrating, you know, it's moving around. You want to make sure that nothing comes loose. In fact, I usually check these terminals whenever I'm in here. Snug them up a little bit. All right. Well, that should do it. The new extruder should be hooked up. Now we just got to route all the wires and put everything back together. I'll give you a little picture of what everything looks like. Well, not a picture, but a video. Let's get you all zoomed in case you couldn't see what I was doing before. So there's your positive and negative right next to it. Your two extruder wires right there. Thermistor is all the way down here. And your fan is over here. They're labeled, so it's not really that difficult. Let's reapply some hot glue just to keep things in place. Then we'll reassemble. So it's not an exact science. I'm just going to put a blob on here. Let me zoom you back out because I'm all over the place with this hot glue. I'm not very good with it. Some guys are surgeons with this stuff. I'm not one of them. So let's put a little blob on that connector there. There, done. Got some on the board, lovely. Oh well. Let's get some on this thermistor here. Same deal. It's trying to make a mess. There we go. All done. Let that chill for a couple minutes and cool off. Okay, got the motherboard bolted back in, and by the way, beer of the afternoon, or I guess evening, is Blue Moon in a tan. You know why? Because it's what I have. All right, let's get some zip ties and start tying stuff together here. Now, if you recall, this bundle of wires that went through the frame rail here, this cutout, that was all nice and neatly taped up. I think I want to do that again, just so nothing gets abraded on that sharp aluminum area, that sharp aluminum housing there. So I'm going to take some electrical tape. Blue seems to be the color of the day, and we'll just wrap the crap out of that. I mean, poop, sorry. Demonetized. Can you say crap? I don't know. I know you guys probably can't see. I'm sorry. It's more important that I can do than you can see, because I can't do anything. Well, I can't show you anything if I can't do it. So we'll do a couple layers of electrical tape here. It's probably better quality than what was on there. There we go, something like that. This keeps everything all neat and tidy. And above all else, safe. Don't want wires rubbing out and shorting on the housing, right? Something like that. And of course, I forgot the BLTouch cable. Always freaking happens, I'm telling you. Let's do one more quick wrap for the BLTouch. There's always one cable that's left out of the bundle, inevitably. It happens every time. Can't tell you how many layers of zip ties I had on this wiring harness just because I made mistakes and added onto this printer. All right, there we go. Got everything in there. So now we can put the motherboard cover back on. I'll do that off camera because that's pretty boring. Now it's time to do some zip tying. This is pretty boring too, so I'm not going to show you all this, but make the harness nice and neat so it doesn't snag on anything. I might... What's that hitting on? What the... How is that possible? But I guess that's off the bed. This is hitting part of the arm. Yeah, hopefully that won't be an issue. I wonder if I should zip tie this cable to this old mount here. Just to make sure it has a good range of motion before I do that. I don't want to zip tie it and then have the wires get caught somewhere. Or not caught, but just run out of slack and not be able to cover the print bed. I always think it's a good idea to keep your wiring neat so you can see where things are going. Wiring doesn't get tangled in anything. What I'll do here is I'll put another zip tie, and I'll put a zip tie before that connector, that Y connector, just so there's no stress on it. All right, so if any of the wires pull, it's not going to pull at the connector. Something like that. Hopefully you can see that. Can you? Yeah, I think you can. I think I did that one right. Maybe one more down here. Something like that. Maybe what I'll do is I'll do a loose one on one of these bolt holes here. So this harness is out of the way, but it can move somewhat. I'm not going to tighten it all the way. Maybe something like that, just to hold it up out of the way. And we can trim the excess off. Hope I hooked everything up right. It'll be fun to redo it now. All right, let me trim this off and then we'll go test it. Sorry guys, I cheated a little bit. Turned it on, forgot to turn the camera on. Right now it's running a bed leveling routine. So far everything seems to be running great. I do definitely need to adjust the Z offset though. So we'll do that after I do give it a couple sanity checks. Now, one big difference with this is how you mount your filament. So rather than having the filament mount on this spool up here, which was reversed, it was sticking out the back and they kind of hooked down along here, I reversed this. So now your filament's going to sit up here, right? and just go straight down into the extruder. Far fewer bends, far less friction. Things should work a lot better that way. Anxious to try it. Now that you've got this fancy new upgraded printer, you might want to protect it. So one of the things I asked for my my birthday recently, I just turned the big 4-0, don't tell anybody, was a cover. If Creality makes a fireproof or fire resistant cover for this, it also protects the printer from dust and all that sort of thing, right? So my wonderful wife, one of the many wonderful things she got me for that birthday was that cover, but unfortunately they come in 2 sizes and I didn't realize that. So my dumb beep happened to add the one to my wish list that was the large size, which barely even covers, well, which almost exceeds the size of that tabletop right there. So I think next I'm probably going to order the smaller version of that cover, which should be perfect and should leave me some room left over on the table. If you guys are looking for a 3D printer cover for this printer, I'll leave a link in the description as usual. So feel free to do what you want with that. It's getting late right now. I think I might call it a day. I guess we'll do that that Z offset maybe tomorrow morning before everybody wakes up in the house. Doesn't take too long, but I don't really feel like doing it anymore. It's getting late. I want to spend some time with the family. Anyway, talk to you soon, guys. All right, guys, so it's the next day. I cheated a little bit this morning, and I did some research online on the best Z offset adjustment procedure, and I learned that newer versions of Marlin actually have a Z offset wizard built in. So I actually ended up compiling my own version of Marlin. I think it's 2.0.9.2 or something, whatever the latest tag release is on GitHub. I compiled that, and this is going to be the first print. I ran the Z-axis offset wizard, and I must have messed up something because it dug into the print bed, and it dug in pretty good before I actually saw it and saw what was happening and pulled the plug. So I ran it again, got a value that was 2 millimeters different than what I got originally. So hopefully that fixes it. I don't have this issue again, but I got a new bed cover on the way. So if this works, I should have one of those benchy boat things appearing here. Now, I realize I compiled Marlin, I cheated a little bit. Let's put it this way, there was no tutorial online that covered the configuration needed for this exact printer with these exact accessories. So if anybody has an Ender 3 Pro with the 4.2.7 motherboard with the BLTouch plug into the BLTouch port on the motherboard as opposed to the Z-Min port, or I guess as you folks not from the US call it the Z-Min port, let me know and I'll cover that in another video of compiling Marlin. It's really not that difficult. You just have to know what configuration tweaks you got to make. So I lied a little bit. I'm not going to actually compile for the firmware, the Marlin firmware for you guys, but I figure as a middle ground, I don't want to cover the compilation in this video. It'll be super long, but if we just, let me just show you the configuration differences that I made from the stock Marlin example firmware, and that might give you enough to go on. So I got Marlin from GitHub. So you go to github.com/Marlin firmware. There's a Marlin directory. This is the actual source code, and I used tag 2.0.9.2, and I also downloaded the Marlin configuration, which you can also get from GitHub. So you can go back here, go back a couple times. Here we go, configurations. And I also downloaded the 2.0.9.2 version here. You can download just by clicking code download zip for both of them. So now I have the example configurations extracted here. So configurations 2.0.9.2/config. Then you go to examples, and again, my printer's a Creality, and then it's an Ender 3 Pro, not the version 2. And I'm using the Creality V4.2.7 motherboard. So these are the 4 config files that they give you that are kind of out of the box for that printer. Now, out of the box is a relative term, right? So out of the box, it doesn't come with a BLTouch. So I had to make some modifications for that. So let's compare. Let's do it this way. Let's do select left files. I'm just going to do a side-by-side comparison and show you the changes that I made to these files. So I'm going to select that, and I'm going to go to my actual modified Marlin config file. So we'll do configuration.h first, and we'll do a compare. So here on the left you see the example, and here on the right is what I ended up flashing to my printer. So you could see here I defined serial port 2 from -1 to 3. I just uncommented it as well. I commented out Z-min probe uses Z-min end stop pin because I don't have my BLTouch plugged into the Z-min port on the motherboard. I have it plugged into the dedicated BLTouch port. And I had, when I did that, and not this right here, not uncommenting use probe for Z homing, not much happened. I didn't really get any action on the Z axis. It wasn't trying to home, it was doing some weird stuff. So I tried this on a whim by uncommenting this, and that seemed to solve all the problems. So again, on the right, this is what I'm using right now that seems to be working for this printer. Again, it's a Creality Ender 3 Pro with a 4.2.7 motherboard with the BLTouch and the BLTouch plugged into the BLTouch port on the board. So here I defined BLTouch right here, just to turn it on. I set my nozzle to probe offset from the factory 10-10-0 to minus 44 millimeters, minus 7, and minus 4. This thing should be actually like maybe 3.95. I got to go check the... In fact, I think I took a picture of it. Hang on. What are my offsets? Yeah, so the offset I'm writing right now is actually minus 3.6. Hopefully this takes integers. So I measured the X and Y offset with a caliper. I just got it as close as I could. And the Z offset, you can use the wizard to set that. I enabled auto bed leveling by linear. I turned on Z safe homing. Okay, so that's one configuration file. Now let's look at configuration ADV. We'll do select left file on that one. Actually, let's do it the same way. So go to examples, select left file, and we'll go to Marlin here. I didn't change too much in this one. So when I didn't turn BLTouch set 5-volt mode, when I didn't turn that off, I got a compilation error. So I compiled that out. I commented that out. And here is where you turn on the probe offset wizard right here. So again, that was commented out. I uncommented it. I also uncommented baby Z probe offset. Don't know exactly what this does, but a lot of folks seem to do that. And I also uncommented this section down here. When I had this section commented out, if you use Octopi will complain and say your printer's firmware supports host action commands, but they're disabled. So once I uncommented this stuff here, again, examples and reality, once I uncommented these here, then that solved that error. And that's really all I changed. Everything else is from the stock configuration files. I compiled it in Visual Studio Code. Again, if someone wants to see this end-to-end, happy to do it, but it's covered elsewhere, and I don't want to make this video 1,000 miles long. So once you make those changes, you just hit compile, and I'll do this build here. If anybody needs those files, if you want me to send them to you or whatever, again, you're going to have this exact same printer and this exact same configuration. If your printer is different, they may not work out of the box for you. So you compile, and then once you have your binary, you just copy one of these bin files, the bin file that you just compiled to your SD card, stick it in the printer, you're good to go. Alright, so hopefully that gives you some insight as to what I changed and what worked for me. Again, it may work for you as well, but you'll have to have pretty much the same printer, same configuration. So let's go back to watching our print. Okay, the bed is the bed is up to temperature, and the extruder is only a couple degrees off, so the printing should start any second. I'm going to have my hand on the power cable just in case it does this again. I really don't want to dig into the bed any more than it has. Glad I didn't damage anything. Let's see what happens. So we're at 196C on the extruder, 197, so we should kick in any second. Any day. Anytime. There it goes. Alright, so I'm going to be on the ready with this power plug, getting ready to yank it. I'm watching carefully. Please work, please work. Oh, it's doing more probes? Okay. I guess it's doing another leveling routine. All right, I'll pick it up when that's done. Okay, it's doing the last 2 points. Here goes nothing. Hand on the power cable again. Last point. Okay, it doesn't seem to be doing the same thing. That's good. It doesn't seem like it dug into the bed plate. I don't know why I did that the first time. I must have messed up. So let's see if this gives us a decent first layer. Seems okay so far. Let that run for a couple minutes. Alright guys, we're about 45 minutes into this print and I realized I cheated and I had it supports abled in Cura when I sliced this benchy. So I'm going to start over and do it the right way because support's cheating with this. Alright guys, there's the completed benchy. Quality overall looks pretty good. I don't see any major differences between this benchy and before. Certainly no flaws. I could probably get a little bit closer on the Z offset. So it's not a bad first layer, but it's a little bit far from the print bed. I might adjust it after I replace this magnetic cover here, which I ruined earlier. But yeah, overall I'm pretty satisfied with this. Come on, focus. There we go. Anyway, so there you have it, guys. That's a little upgrade to your Ender 3 Pro or Ender 3. If you guys like this video, please subscribe, hit that like button. Thanks for watching and stay safe, everybody.